Hi, Accelerated Algebra. So this is completing the square part 2. You guys did a great job on part 1, and now we're going to take it up a notch. So remember last time we had things like x squared minus 6x plus 12 equals 19. And our goal was to write the equation in this kind of form. Some kind of binomial squared equals a number. And then we could solve with square roots, just like we did here. Now, what if we have something other than 1 as the coefficient of x squared? How does that complicate things? Well, here's an example, what we've got right here. Well, in this application, it's really not that much more work, because all you really need to do is start with this, divide everything by 5, so that the coefficient of x squared is in fact 1. So if you divide by 5 on this side of the equation, you're going to have to do it over here as well. So then I've got x squared minus 2x equals 23 over 5. So that's a little bit annoying because it's a little bit messy, but no big deal. I'm going to play the same game here, where I'm going to take this coefficient of the x divided by 2 and square it to find this number right here. So negative 2 divided by 1, negative 1, and that means that I'm going to add 1 to both sides. Now I can write this as x minus 1 squared equals 23 over 5 plus 1. Now these numbers are not going to come out as pretty, but it's the same steps as before. I just need to take the square root of both sides. And we'll round our answer to the nearest tenth. So I have two solutions just like before. I've got a squiggly equals because I approximated. The other thing that we use completing the square for is converting things to vertex form. This is super useful because we've talked about the benefits of vertex form over standard form. So let's just remember what those two forms are. So remember, in vertex form, we like this form because we can really easily see the vertex. We know the vertex is HK. Here we have to do the axis of symmetry. So if we could convert from standard form to vertex form, that would really work out for us. So that's our goal. Let's look at an easier example first. Let's say we start with f of x equals x squared minus 4x minus 26. So remember, I want to write this as f of x equals something squared plus something. I just have to find them. So the first thing that I'm going to do is just kind of separate out this 26. I'm not going to bring it to the other side like we did before, but I'm going to separate it out a little bit. So I'm going to rewrite my given equation as f of x equals x squared minus 4x. I'm going to move the 26 just over a bit. Now, I don't really have two sides because even though this is a side, I don't want to add things over here. That's like my y equals side. So instead I have to do the trick a little bit differently. I'm going to do the same thing of divide by 2, so I get negative 2 and square it. I get a positive 4. Now if I add 4, in order to cancel that out, I've also got to subtract 4. What have I done here? I've really just added 0, which is fine. If I add 0, I don't change something. Great, so I'm just going to rewrite what I have above. This time I'm going to write it as f of x equals x squared minus 4x plus 4 minus 4 minus 26. Consider this part together and this part together. And the reason why I want to do that is because this part can be written as x minus 2 squared, and this is simply minus 30. So now I've got x minus 2 squared minus 30. So that's vertex form, and in fact my vertex is 2 comma negative 30. Remember, the minus sign is part of the formula, so my h is 2 and my k is negative 30. There's my equation in vertex form. Let's do a slightly harder example. Okay, this time we're going to have h of x is 4x squared minus 28x plus 49. Now this is a little bit harder because we have to deal with this 4. And now we can't just divide everything by 4 because I don't really want to divide this side by 4. I want to keep it just as h of x. In the end, this is going to look something like h of x equals 4 times something squared plus something. So it's still going to be in vertex form. All right. What are we going to do? Well, we need to factor out a 4. But we really only need to factor out of these first two terms, because those are the ones I'm going to use to complete the square. Great. So now I'm thinking, all right, what do I need to add inside these parentheses here? Well, I divide 7 by 2, so I'm going to get negative 7 halves, and if I square that, I'm going to get 49. So if I add a 49 over here, 49 over 4 over here, I need to subtract it as well, so that really all I'm doing, remember here, is I want to just add 0. Now, here's the tricky part. This 49 over 4 is actually being multiplied by the 4. So since it's in the parentheses, it's being multiplied by that 4. So what do we have to subtract to make this all come out right? Well, I'm going to have to subtract 4 times 49 over 4. All right, let's write this out all carefully again so you can see exactly what I'm doing here. So I've got 4 times x squared minus 7x plus 49 over 4. Fine. What I really added to my equation is 4 times 49 over 4. Now I've got to subtract that same thing, so that effectively I'm just adding 0. Okay, let's simplify. This turns out to be 0. Right? This gives me negative 49 plus 49, so that's plus 0. So my vertex here, if I were thinking about it, would be negative 7 halves, 0. You could also think of it as negative 3.5. There's my vertex form. I would probably write it like this. You might want to go back and try this example again on your own. You'll also have some Khan Academy practice, or perhaps some other practice on Schoology today. Great. Thanks so much for watching.